Numeric derivatives. This is one of the niftier things that I like about this calculator. That can do derivatives, and we'll see later it can also do integrals, but only the numeric versions of it. It can't convert to another equation. It can only tell you what the value of that particular derivative equation is, that function, at a specific point within the function. So this is an x function, so it would be, for example, the one I show there in the third bullet point. We're asking for the numeric derivative of x cubed minus 2x that was calculated at x equals 2. So that will tell you, for those of you who understand derivatives, hopefully you do if you're going to take the FE, that is actually the slope of the line tangent to that point on the curve. Let me give you an example of the calculation. So here's one where we want the derivative d to the dx of x to the fourth power plus 3x, but we want to know it at the point of x equals 1.5. So what we do with the calculator here, that happens to be a secondary function key, the derivatives right here on the log. So I hit second, I hit the log key, it goes automatically into the fill-in for the derivative function. To do the x4, the first thing you have to do is put in x. There's one key I didn't explain here before. It has in it a lot of options as you hit it multiple times. It can be X, Y, Z, A, B, C, D. They're all defined on that key. So if I hit it the first time, it is X. But I don't want X by itself. I want X to the fourth. So now I hit the X to the arbitrary power with the square box there. Boom. Now I can go ahead and put the 4 in as the power that I want. Now I got to arrow right because it's still in that function in case I wanted to make it x to the 40 something else or 400 and something. So I get out of the power, and now I can put the actual addition sign. Use the standard addition here. So we're going to put in plus with the silver keys, and then we're going to put in the 3x. So I actually just type in 3, and then I hit this key again, and it's x. And now our arrow over, it's asking me for what the point value is. What x point do I want? I just type in 1.5. And I do have to get out of that, so I do arrow over to get out of the entry of the point. Once I see it blinking like this off to the side, I know I'm complete function. Be careful about that, because if you hit it, the enter at the wrong point, you will get a bad calculation. But if I hit it now, what do I get? I get 16.5. So that's saying that the slope at that point of x equals 1.5 is 16.5. Same calculation I got before. Now for derivatives, it supports, again, numeric derivatives. The key is, again, the secondary function, in this case, to the e to the power 10, base 10 to the power. So if I do second and I hit that key, it goes into the actual integral function, as shown in the second bullet on the screen. Okay, now for an example of the numeric integrals. I want to calculate the integral, which everybody should know if they're taking the FE exam, just like on the derivatives. This represents the area under the curve to the x-axis for a particular function from some starting point of x to some ending point of x. I want to enter in the function. I hit second, and I hit the numeric integral function, which is the e and the 10 to the power function, and now we have the actual integral formula that can have the numbers plugged into it. Now I want to enter a -3. To enter the -3, however, I have to indicate a negative number. We do not use the minus function key for that. If you were to do that, you'd get a function syntax error on the calculator. That probably will happen to you several times before you catch on to it. You have to hit this key, which is specific for assigning a negative value to a number. It has parens around it. So we hit this key first to assign that we want to enter a negative number. Negative. And then we can hit the 3. And now we arrow up to the endpoint, which is 9. Since that's a positive, we just have to enter it. Now we go into entering the function. We want x squared plus 3x minus 6. Again, we start by hitting the actual letter x here. We have a lot of choices, x, y, z, etc., etc. We hit it once for x. But now we don't have to hit the arbitrary power one. We can hit right into x squared, and we're done. We don't have to enter 2, we don't have to arrow to the right. It's now ready for the plus sign. So I now can enter the plus sign, which is a function. And now I can enter directly the 3x, the number 3, and then I hit this x key again. Now I want to enter -6. Now, this case, be careful. We're not entering a -6. The value of the 6 is not meant to be a negative number. This is hard to grasp at first, but we want the function key in this case. So we do want to hit the silver key for negative. Sometimes it's hard to decipher which is which, and it's going to take trial and error on your part, I'm afraid. But this one is the function. The individual negative sign is when you're filling in generally a box or a table entry. This is not the case here. There's no box there. So it's looking for a function. So I hit the negative function, and then I hit the number 6. And then I arrow over and get myself out of the entry of it, and then I hit the enter key to calculate this. Notice it takes time to calculate these integrals. 288 is the value. That's the area that exists under that curve between -3 and 9. Let's see what I calculated before. 288. Now we have a lot of other special functions that lead into statistics and data analysis. For example, factorial, combinations. Now what is a combination? You have some number of items and you're taking some number of them at a time out of that collection. So for example, let's say you have 52 cards and you want to pull out 5 cards. You're playing poker. How many different combinations of 5 cards can you get? Now permutations, it's a little confusing, is very similar to that. The only difference between the two is if you were doing that, 5 cards out of the 52, chances are the order does not matter. So if the order doesn't matter, then the NCR for number of combinations where the order is not significant, as I've indicated in that description, is the one you'd want to use. But if the order is significant, suppose you're playing cards where it does matter, I don't know any game that does this, where if you draw a 2 and then a 5 and then a king, that's different from somebody else drawing a king and then a 5 and then a 2. If that's the game you're playing and that it does matter, the order, then the one you want is the second one where the order is significant, the permutations. These functions are built right into the calculator. So for example, I want to take a unique sequence of 10 cards and draw 4 at a time. But let's say that it does matter, the order in which they come out. Because this is not a regular card game. It's to see the number of unique sequences I can pull out. So in this case, 4, 3, king is different than king, 4, 3, and different than king, 3, 4. And on and on. You have many more combinations when the order matters. And that's what the real difference is. You will see a much larger number on the NPR versus the NCR. So for this one, we want the P because we're saying unique sequences. So to do that function, we have a key for that. And it's actually labeled, it's the same key that you punch up for all of these combinations and permutations. It depends how many times you hit it. So what we do is, the way this works, and this takes some getting used to, you type in the number of items in the total set first. Then you hit the key, and then you hit how many you're drawing out. So in this case, the example is 10 cards drawn 4 at a time. I first type 10. Then I hit this key, and I'm going to hit it more than once. The first time it does factorial. The second time it does NCR, combinations, but I want NPR, permutations. I hit it again. Now I enter how many I'm going to draw at one time. So we put the 4 at this point, and we hit enter. 5,040. Now you can go ahead, I'll leave it up to you to try it with the combinations. And you will see that there's a totally different number for that. You have much less combinations than you have permutations. What did I get last time? 5,040. Now, probability and statistics. This has some very powerful functions, and I think you should study this for the FE because there is a lot of material on this inside of the FE manual that they give you online. There's a lot of examples in whatever study guide that you use, and the normal PDF, which I have defined here, is compute the probability density function, called a PDF, for normal distribution at a specific value. This is a bell curve that we're looking at here, and we want to get the actual PDF value for a specific value of x. Well, you could look it up in the tables that are provided in the book. Chances are that's what you want to do most of the time. But let's say to give you an oddball number that you can't find in the table, you may want to use this function, and this is only one example. And it requires 3 things entered to it in order for it to do the right calculation. It needs the values for x, it needs the mean, or the mu, what is the average, and it needs the sigma, which is basically the standard deviation for this particular curve. So as example, let's say I want to calculate the normal PDF using these 3 inputs. X of 55, that's a total sample set. The mean of 59, that's the average. And the sigma of 5, I would come in here and hit second, stat register distribution. I have to go over to distribution, because normal PDF is part of that grouping of statistical functions. I'm not here to teach you statistics, I'm just trying to help you understand that you can use this to solve some pretty complex problems. Number 1 is normal PDF. There's other ones too. There's normal CDF and there's inverse normal. But we're going with normal PDF for the problem I presented. So all I have to do here is hit enter. It's now going to ask me for the 3 numbers. So since I cleared the calculator out before, what's stored inside of its memory are default values. It has an x of 0. I got to type in, it's actually hovering waiting for an input on that. I could go ahead and just hit enter if I'm accepting that, but I'm going to type 55. And then I'm going to hit enter to get to the next entry point, which is the mu, or mean. I want 59 for that. Then I'm going to hit enter again. I don't want a sigma of 1, which is the default. I want a sigma of 5, so I'm going to enter that. Now I got an arrow to the calculator function key over here. Just hit the down arrow once. It's sitting on calculator. It will not execute until I hit enter. So I now hit the enter key. And it gives me a value of 0.05793, etc., etc. That is the actual normal PDF for the values that I've entered. An x value of 55, a mean of 59, and a sigma of 5. And you could actually find that in the table at some point if you looked it up. What did I get before? 0.058. Now, matrices. This is a very powerful function as well. It's similar to the power of doing the calculus functions because there's a lot of power in matrices. I won't go into all of the things you could use it for, but just be aware that you may get a direct matrix type question where it asks you to do certain types of functions on matrices. And this calculator supports 2x2 and 3x3. Actually, it does 1x1, 2x2, and 3x3, but the 1x1 doesn't really make much of a difference. You can do that manually quicker. And you can do various math functions on those matrices. You can also do special matrix functions like determinant, transpose, inverse, reference reduced row, identity matrices. All that is to print out a table that is always the same for the particular dimension of the matrix, whether it's 1x1, 2.2, or 3x3. You can try that yourself and you'll see what I mean. And you also have all these math functions listed on the left here. You can add matrices, subtract matrices, multiply matrices, multiply by a scalar value, for example, 2 times a particular matrix, or you can also multiply a matrix times a vector. I won't get into the details on that because there's some complications with it, but the calculator is capable of doing it. So for example, I have 2 matrices. The one on the top left, 2, 1, 0, 2, 3, 4, and 0, 2, 2, and I'm going to multiply that by the matrix on the right. That's 1, 3, 1, 2, 4, minus 2, 1, 0, 2. And this is the actual symbolic definition. This is important to know, where it shows bracketed capital A times bracketed capital B. Sometimes that's the way they'll show it to you later in a multi-part problem. So to calculate this, we go into the matrix, which is a second, and the math function. The first thing you have to do is you have to define 2 matrices. This thing will support up to 3. So we go into edit, and you have either edit the A, the B, or the C. I believe that's all we have available to us. Yeah. So let's make the first one A. It makes sense. So I'm going to edit A. I hit enter on that. It is asking me the dimensions of it, and you can do the rows and columns differently. I want this to be a 3 by 3. So for the rows, I'm going to scroll over to 3, hit enter. Then it's waiting for the columns. I'm going to scroll over to 3 again, hit enter, and then I'm going to hit OK. It immediately goes into me asking if I want to fill in the data for that matrix. I know what my data is. I want a 2. I hit enter. The 2 will go into the top left box. Then it moves to the right. Then I want a 1. I hit enter. 0, I can just hit enter at that point. To accept it, I have to hit it twice. It might be easier to just type 0. Then I want 2 again. I want 3. I want 4. I want 0 again. Well, this time I'll do 0, enter. I want 2. I want 2. And when I hit enter that last time, the matrix values are set. So I do second matrix again. I go into edit, but this time I'm editing B. Notice that it now has a 3 by 3 defined for A. So it knows what A is. It has been dimensioned. You could assume that it may or may not have been filled in, because somebody could have just skipped the data entry and it could be all zeros. They may have a reason for doing that. So now I hit enter on the B, and I want to do the same thing. Dimension the rows for 3. I want to dimension the columns for 3. I want to say OK. And now I enter in the data. 1, enter, 3, enter, 1, enter, 2, enter, 4, enter. Oh, this is a negative. What do I have to hit here? It's not a function I'm looking to enter. It's data entry here. So I hit this negative button right here first. So I do -2, and then I hit enter. And then I want 1, 0, and 2. It is now done. It's filled in. So now we have matrix B defined. I hit clear again. Now, this is nifty because all I have to do is pick those 2 matrices. I have to still use the matrix function to do that. So I hit second matrix. But now all I'm interested in is the name. That's the first column there by default. So I want A. It's already on 1, which is A. All I have to do here to select that one is hit enter. What am I doing to it? I am timesing it. So I'm going to hit the times key. Of course, you use the alternate symbol for times. Now I have to enter the second matrix. Again, second matrix. This time I scroll down once to the B, the second entry there, and I hit enter. Now I have A times B in matrix form. If I then hit enter to this, I have a new matrix shown to me. That is the actual new matrix produced by multiplying the left matrix A with the right matrix B. It saves a lot of time. If you try to do that manually during the test, it will actually cost you at least 5 times the amount of time that this costs to do it with the calculator. So I would study this function as much as you can. Now those matrices are still defined. I can later on use them again. The only way they get wiped out is if I change them or I do a full reset. Now I want to talk about vectors. Similar thing to the matrices. We have the functions that support. You can add vectors, you can subtract vectors, you can multiply a vector by a scalar, and you can also multiply, as we said earlier, with the matrices, a matrix times a vector. And then the vector-specific functions over on the right are dot product, cross products, and normal magnitude. I'm not going to go into what those mean. That's not the point of this lesson. But this calculator can calculate all those for you, and some of them are not easy to calculate. Okay, now the vector example that I want to do has 2 vectors in it, u and v, with the values shown on the screen. And I want to calculate the dot product for those 2 vectors. Very similar to the matrices, I would go this time, however, into the vector area. So I hit second vector. Very similar screens as well. This time I will do the edit on the first vector indicated u. I'm editing that one, so when I hit enter, it's going to ask me what the dimensions are for that vector. I'm going to give it a dimension of 3. It's going to confirm with the OK. I'm going to say OK, and now it's waiting for the data. So I'm going to do 3, enter, 1.5, enter, 4, enter, And we're done after hitting that final enter. I will then clear, again, as I said with the matrices, it does not clear out this data. It just clears the screen and allows me to do the next function. I do it again for the second vector. Second vector. This time I go into the edit, but I'm editing the second one, V. And I hit enter. It's asking for the dimensions on that one, also 3. I confirm with the OK. Now I can enter the data. 2, enter. 2.2, enter. 2.8, enter. And again, we're done. That vector is now defined with both dimension and data. And I clear it. Now I want to do the dot product. I can do that directly with the actual math available for vectors. So if I go in here and hit second vector, but this time I pick math, the very first choice is dot product. So all I have to do now is hit enter. It opens up dot product function. But now I got to give it the two vector names, again separated with a comma, just like we had to do when we were dealing with the real numbers that we were converting between each other. So now I hit second vector. Now I'm only interested in the name. I'll pick U as the first one. I'll hit enter, but now I got to put a comma. So I do second period, it gives me the comma. Now I go second vector again. This time I want the V vector, so I scroll down one under names. I hit enter and it's there. And again, I don't have to close the parentheses because it's automatically assumed. So I just have to hit enter and we'll see what I get. 20.5. See what I got last time I did this? 20.5. So we match. Hopefully you've learned something today about some of the techniques to use using the calculator. If you did gain something from it, do me a favor. It would be very helpful if you could subscribe to this channel. Simply click on the little head here. There's no cost, and it's easy to do. It would really be helpful. Thank you.